All right, practice problem number 4, associated with sample problem C. An airplane flying parallel to the ground undergoes 2 consecutive displacements. The first is 75 kilometers, 30 degrees west of north. The second is 155 kilometers, 60 degrees east of north. What is the total displacement of the airplane? Okay, now this one's going to be pretty tricky. So, not super tricky. We're going to use the exact same sign conventions that we've used in the past, but we really need to define our coordinate system. So again, here's north, north, positive. We go east, positive, south, negative, and then west. Oh, sorry, negative. Sorry, west is negative. And we're going to have to use these sign conventions in this one, okay? Because we haven't done a lot of this, but we got some movement west of north. Yeah, so the way to represent that mathematically is we're going to need that sign convention of the negative. So what we have here, the first movement is 75 kilometers with an angle west of north. So our triangle, for as far as I can remember, the first time ever, is actually going to be starting out going this way, right? Because that's north, according to the coordinate system that I defined. That's north. And so we're actually west of north. So this is the 30 degrees. 75 kilometers. Let's write that down. And the second is 155 kilometers, 60 degrees east of north. Okay, so this way's east, right? That way's east. From north, again, where's perfectly north? Again, east of north. Not from the original direction, okay? Not from the original direction, from east of north. So that means we're going to be going this way. How much? 60 degrees. So 155 kilometers. Alrighty. So I can fill in my triangles so that we can see it just a little bit better. I still have my 2 triangles. Okay, I don't even have to do 3 triangles like I did in practice number 3. The issue is I'm going to have to use sign conventions to get the math right. So let's start with the first triangle. So here's my x component, here's my y component. Again, y component, x component. Let's see, let me do my arrows so this makes more sense. Okay, so let's start with the first triangle. I'm going to have to decompose this into some x and y components. So x component of the first triangle is actually going to end up being a 30-degree change, but it's in the west direction. So it's actually going to be going to need to be a negative direction. So again, my first resultant, okay, 75 kilometers. Now, pay attention. A lot of times when we do, when we are trying to find the x component, we're going to use cosine a lot. Not here, because again, go back to your definition of sine and cosine. 30-degree angle is right here. The x component is opposite over hypotenuse. So I'm actually going to use the sine of the first angle. So it ends up being 75 kilometers times the sine of negative 30 degrees. Okay, it's negative 30 degrees because the movement was to the west. Okay, and again, I define west as negative, so it's a negative 30-degree change. So using 2 significant figures, that is a negative 38 kilometers. Negative. It's very important here. All right, but what is the y component of that first triangle? There's going to be, cosine, again, adjacent over hypotenuse, of negative 30 degrees. Negative 30 degrees. This ends up being a positive 134 kilometers, which makes sense because it's pure north. Okay, it's pure north, and that's a positive direction. So we have our components from the first triangle. So let's try the second triangle. Again, here's that 60-degree angle. X here is opposite, right? Opposite over hypotenuse. So it's going to be sine again of the second angle. So 155 kilometers times the sine of 60 degrees. This is going to be a positive 60 degrees because the movement relative to north is east, and we've defined east as being positive. So that's going to be so 60 degrees, and calculator tells me 65 with some significant figures. No. Oh gosh, did I copy this? Did I copy this down wrong? Oh yeah, for all of you who are freaking out, yeah, you're right. That's not what your calculator said at all. I did backwards. 65. Sorry about that, y'all. I got my components backwards. Yeah, that should be spot on, right? That first y component should be 65 kilometers. This second x component should be 134. Sorry for any confusion. And if you were freaking out, you've been validated. Um, 155 kilometers cosine of 60 degrees. Cosine is 77.5 kilometers. So I need to do some totals. X total and y total, which is simply the addition of those individual components. As long as I didn't screw them up again over here. So I'm going to add in, here's the importance of this first negative number. It's negative 38 kilometers plus, that's right, yeah, 134 kilometers, which ends up being 96 kilometers. Okay, if you didn't use the appropriate sign convention, you'd get 172. Is that right? 172 kilometers. And that'd screw up your resulting triangle. And then the y's are actually pretty straightforward because they're both positive. Ends up being 140. Let's go 3 kilometers. All right. So let's start with our Pythagorean theorem. Delta x squared, delta y squared, all under the radical. Ends up being 96 kilometers squared. Whoop. And was it 143 kilometers squared? Still under the radical. So what does that end up being? What is this? All right. If you want to do significant figures, you could just go 9,210, but I'll pay attention to my significant figures afterwards for my final answer. Gosh, what does that end up being? Is that, what did my calculator say? Yeah, we're still square rooted. Hope I'm not freaking you guys out there. Oh, what would that be? 6? Yeah. Just messing stuff up here. It's a very dirty practice problem I've written right here. It's not very clean. But let's do my actual square rooting and end up with a magnitude of 172 kilometers. Now, if you are kind of taking into consideration significant figures in the middle of the problem, it's not going to affect your final answer, because when you square root this down and consider three sig figs, you're going to get 172 either way. And so I challenge you to take all of the figures that your calculator gets when you do this squaring here. Just leave them all in, do this action in the step, get to here, and then square root it. And I challenge you to come up with something other than 172. So trying to freak out too much there. But we need the direction here, so let's go inverse tangent. Oh my gosh, I didn't draw my triangle, so I don't know which one to do. So I have I have an x component of 96 kilometers. It's positive. Okay, it's positive, so it's going to be going that way, right? East positive. 96 kilometers. And my y component is also positive. That's 143 kilometers. So here's that angle. So this is going to be this angle. Tangent is opposite over adjacent. So opposite over adjacent. That tells me to put the 143 kilometers on the top here, 96 kilometers on the bottom. Bust that into my calculator. Two significant figures. I'll end up with 56 degrees. But the question is, in what direction? So we were moving east, but then we moved north. Okay, and so I'm gonna say going this way. 56 degrees north of east. Yeah, and so that'll be part of my final answer. But again, you could represent this differently. What would that be? 34? Am I doing that right? It'd be 34 degrees east of north, right? That would also be a legitimate answer if you wanted to. Again, so here's your north, and you want to go east from north. Right, that would be 34 degrees east of north. But again, either way is okay as long as you define your coordinate system and you're specific with your direction.